Good evening, guys. Am I audible? Is my screen visible? Dear participants, can you please confirm? Good evening. Yes, thank you. Thanks for the confirmation. Good evening, guys. Good evening. So, today is an important day because we are going to implement what we have learned in the previous classes. So, today we are going to see a machine learning project, and it will be based on the classification in supervised machine learning. Okay, so we are going to see an entire project today. So, we'll try to cover it entirely in today's class. Okay, so we have a very short time, which is nothing but in this 1 hour we have to complete an entire project. So already I have written all the code, so I'll explain you one by one what is happening, what are the steps we are going, so it will be clear for you as well. Okay, so good evening once again, and this is day 12 of data science Naan Mudhalvan virtual internship, and I welcome you all on behalf of pantechelearning. Okay, can we start, guys? Can I get thumbs up? So we are going to start with a machine learning project. So this is our first project we are going to see in machine learning. So it comes under supervised learning and then that classification project. In tomorrow's class we will be discussing about a regression project, and day after that we will be seeing about the unsupervised algorithm as well as a project in that class. So that's what the plan for the next 3 days. Okay, can we start, guys? Can I get thumbs up? So the project we are going to see today is telecom customer churn prediction. So this is what we are going to predict. So what is churn? I'll tell you, I'll explain it in a bit. Okay, can we start, guys? Can I get some response? Are you guys ready with this project? And regarding assignment, have you guys completed and submitted it? Because tomorrow will be the last date to submit the assignment, so make sure you are completing it as soon as possible. Okay, in tomorrow's class I'll be distributing a link for you to update about the assignment too, so make sure you are submitting the assignment before tomorrow. Okay, before tomorrow's class. So we'll start with this telecom customer churn prediction. So what is a churn prediction? It is a common use case in machine learning domain. So if you are not familiar with the term churn, which means leaving the company, for example, there are many telecom companies, right? For example, if you are saying we have Jio, Airtel, so Idea, Vodafone, some companies like this. So you are a customer for their company, and if you are left their company, you are not recharging. Okay, you are left the company and went to some other company. So this company, okay, they are analyzing their data. Okay, how much, like in the past few months or in that particular period, how much persons left out. Okay, what are their details? And this company, okay, comes to a machine learning scientist or a company which does data science. Okay, so you are a data scientist and you want to analyze this data and give them some like advice. With that they can reduce the churn, which means reduce the customers who are leaving the company and increase their tenure or their income. Okay, so this is what you are going to do with the data. Okay, you are a data scientist and you want to perform this task for that company. So this company is giving their data for you, so you have to do some processing and analyze it, and with that you are going to give a predictive model so that they can predict. Okay, with the user input they can predict whether this customer likely to be a churn or they will likely to be stay in that company itself. Okay, clear, guys? Clear about what is the task we are going to do today? Is it clear? So I have a data set for this. It is available in Kaggle. You can search many type of data like this. It is customer churn prediction, and this is especially telecom company. Okay, so telecommunication customer churn prediction data set. You can download it from Kaggle. You can search it. Okay, so we'll start with the data set. First I'll open the data set and show you. So this is the data set I'm having. So I'll open it. So this is our entire data set, and they have contained something like the customer ID, the gender, whether they are senior citizen or not, and all those details. So what is the, like, we'll see about it. Okay, so finally we are having this churn which is yes or no. Okay, if it is yes, which means they have left out of the company, like they left this telecom company and went to some other company. Okay, so we are going to analyze this and predict yes or no. So that's what our output will be. So this is a supervised learning because it has labeled the data, and it comes under classification problem because these are not continuous output, this is the discrete output, and you are going to, it is a binary classification problem. Okay, so we'll start with this. So let me open my collab file. I already have the code, so I'll explain you one by one so that you can also understand it clearly. Okay, so don't get confused. If you have any doubt, you can interrupt me inside, okay, in between in the chat box. I'll be listening to it. I'll also try to like go in step by step so that you can understand better. So this is the dataset attributes. So this is just a text. Okay, for information I have created these texts, and what are the columns we are having. So this is the dataset attributes. We are having the customer ID, and I think this customer ID has nothing to do with whether they are like in their churn or not. Okay, and their gender, this may play a role, and whether they are senior citizen or not. Okay, above an age limit, old people, they comes under senior citizen, so there they are or not. And their partner, whether they have partner or not, they have dependents or not, yes or no. Okay, tenure, so number of months the customer has stayed with the company. Okay, how many months this customer is a customer for this company. And phone service, whether they have adopted phone service or not. Multiple lines means whether they have multiple lines for this phone service or not. So if they have phone service, then this will be applicable. Okay, if they don't have phone service, then it, like, they cannot have. Okay, so this will come under no phone service. And the internet service, okay, whether which option of internet they have chosen, whether it is DSL or fiber optic, whether they don't subscribe to this internet option. And then some other options like online security, online backup, device protection, tech support, streaming TV, streaming movies. Okay, these are like a combo. If you get this phone service multiple lines, you'll get all these additional support. So we'll discuss that when you analyze the data. Okay, then the contract term, whether it is a month to month contract or 1 year or 2 year. And then whether it is a paperless billing or not. Okay, what is the payment method, whether they have done it using electronic check, okay, mailed check, bank transfer, credit card. And the monthly charges, how much it is, what are the total charges for the customer, and finally whether the customer is churned or not, yes or no. Okay, so this is the entire feature of the data set, and we are going to use or analyze over it. So where should we start, guys? You got this data, but you want to understand, we got this columns, okay, but you want to get to know further more about the data. So what are the things present inside, what is the trend, you have to analyze. So what will be the first step here? Tell me, guys, quick, waiting for you. What will be the first thing it will be better to do? The first thing will be better to do is analyze the data. Okay, so you want to analyze this data set. Okay, you have to perform data analysis. Once you done that, you can get some actionable insight. Yes, correct, performing EDA, very good. Once you done this exploratory data analysis, okay, you can get some idea about the trend or what all happening inside. So it will be useful information. And then we can go into the pre-processing the data. So what all things we should do for the requirement, we'll do that. And then we'll create some models here, and whichever the model is better, we'll use and create a predictive system finally for the company, so that the company, if they have one customer's detail, if they enter, they can predict whether that customer is prone to churn or not. Okay, that's what our final aim will be. Clear? So starting with, I'm importing the necessary libraries. Import pandas, numpy, cborn and matplotlib. Okay, so I have loaded my dataset here. I hope it's not loaded. Wait a minute, guys. Desktop. Here it's. Okay, let it load. And let me import the necessary libraries. It's done. Okay. So now I have to load the data in this variable data. I'm loading it here. Okay, so we'll see the head of it. So we should see all these columns, right? All these attributes should be present there, and it is available. See here, customer ID, gender, they are senior citizen or not, partners or not, dependents, The tenure is the months they have been with the company. Then phone service, multiple lines present or not, then all these additional things, okay, given by the company to the customer, whether they are adapted or not. Okay, these are like some companies are providing, right? You may like spend some additional cost, with that they give some other additional options for you. Okay, like streaming movies, TV, any online platforms, etc. So the contract type, the billing type, payment method, monthly and total charge, finally churn column. So, okay, so all these things will be in X and churn will be in Y because it's the output. And now I'm going to drop the customer ID because it has nothing to do with the churn or not. So I'm just dropping that from the data entirely. So I pass in place equal to true. Clear? So we'll go and see the head once again. Okay, so let me go and get the info. What this info will give? How many non-null counts, what is the data type present here, it is giving me all these things. So totally it seems like 19 columns there along with the churn. Okay, so I'll copy the columns here in this column, okay, just column names. So that will be it for my reference. Okay, first we are going to analyze the target variable. Okay, I want to see the target variable. So tell me guys, what is the target here? What are we going to predict? Tell me guys quickly. What is the target variable here? It is nothing but the churn. Okay, so we are going to analyze in churn what all things present. So that's what I'm going to get. Okay, using count plot, you can do it with the help of what it is. So I can go and get like data dot, what is the column name, churn dot value underscore counts. Okay, this will give me how much things present inside. Okay, so totally no means the customer is with them, and if it is yes, which means churn, which means the customer left them. Okay, so it seems like yes, good churn. So it seems like 5,000 nearly in this entire data. So totally how much it is? Nearly 7,000 rows. Okay, 7,000 customer details. Nearly 5,000 customers stayed with them and 2,000 customers left them. And it seems like an unbalanced data. You can see, right? It's not balanced, this output. So the machine learning model can place some weight on this one because this is the majority. So we have to balance it. So I'll tell you what we should do in the later part. So now I'm just going to set theme, okay, using SNS, style equal to dark grid. So the visualization will be different, and the palette for all the things I'm setting it to set 1. Okay, so this is a color theme which red and blue combo, it will be good. Okay, so this for just visualization, and I'm just setting the count plot. Okay, so this count plot from Seaborn, we know it, right? So we just want to pass it, so it is going to get this value count and plot it for you. Okay, and the orientation is horizontal I am getting. Okay, so this is what the count plot is. So totally the churn customers are nearly 2,000, and the customers stayed with them are more than 5,000. Okay, and the output is imbalanced, we will discuss that later. And the observation from this is there is imbalance in the target variable of this data set. Okay, clear? So every time we go and do something, I'll be giving some observation below it for our information, for us to tell the company or the stakeholder who did ask to do this job. Okay, so next one, we are going to take the categorical features. So what is a categorical feature? So when you analyze this data, you see like many places it is yes, no. So these details are known as categorical data, or this charges, these are numerical or continuous data. Okay, so these are categorical data. So I am going to take all the column names which are categorical. So because I want to analyze them separately. See here. Okay, that this we have completed. Next thing will be categorical features. So I'll load the head, and I have selected which all things are categorical. I have loaded it, okay, in a list, just the name alone. So I'll run this. Okay, so for all of this, okay, this is, wait guys, so this is just a count plot of all the columns. Okay, all the categorical features, just the count of it totally. Okay, I'll just zoom out a bit. Okay, the count of gender. Okay, it seems like both male and female are equal. Okay, so this gender column has nothing to do with the prediction. Okay, if you like, I'll show you in a bit with that. Okay, the senior citizen count, so senior citizens are less. Okay, 1 means yes here. So the count of partner, yes and no, it's equal. Dependents, yes is less. Okay, phone surveys and all these things are count plot. And before going into this, so first, okay, I'll show you some other thing. This is belongs to the senior citizens. Just ignore this part because this is a function. Once I explain this thing, I'll explain you with this. So for the senior citizens, I'm going to group them based on the churn data. Okay. So what I'm doing here, see here, I'll take it one by one and show you. First, I'll get the data dot group by senior citizen. Based on it, I'm going to get the churn value and get this value underscore count. So if I run this, see here, I'm taking this and running this only. So it is giving me in the senior citizen 0, which means they are not a senior citizen. The churn, no value is this, yes value is this, whether they are churned or not. And if the senior citizen is 1, which means they are a senior citizen, the no value and yes value. Okay. Now I'm just using this option 2 underscore frames. This will convert this into a data frame directly. Okay. So I'll pass it here. So if I run this, this will be directly turned into a data frame. Okay. So I'm storing it in a variable dot, like for example, I just give an FRE. Okay. So in this, I'm using this dot rename option. Okay. So if I store this and if I run this, I'll get the same table in this FRE. Sorry about the name, I just given. Okay. So in this, I'm just going to use this dot rename. For this churn, I'm just turning into number of customers. Okay. This churn, I want to turn it into number of customers. And the axis as 1, and I'll reset the index. So what this will give you, okay, if you visualize it, you can see here it just turned into another column with like the senior citizen 00, churn no, yes, number of customers. So with that now you can clearly see it, right? So this is what happening here. Okay, so I'll remove this, I'll run this one. Okay, I can hit the head of it. Since it is a data frame, I'll get this one. So now what I'm doing is I'm creating another column for the percentage. Okay, so in that percentage, I'll take this value divided by the total sum of it, which means you can get and multiplied by 100. So this is going to give you a percentage here. Okay, what is the percentage of the persons present there? So if I run head, I can get a percentage. Okay, so if they are not a senior citizen, so nearly 64% has not churned. Okay, and if they are not a senior citizen, 19% have churned. And if they are a senior citizen, 9% have not churned and 6% have churned. Okay. So next, if I run the senior citizen value, see here, I'm just getting the senior citizen alone for them. And in the senior citizen, okay, nearly 58% has not churned and nearly 41% has churned. Okay. See here, if they are not a senior citizen, they are not churning. Okay, the churning of the not senior citizen are less. But if they are a senior citizen, old people are churning the most because that is nearly half of them are going out of that company. This is what this data is telling us. Okay. So now I'm going to, so I'll just use the bar plot to visualize this. See here. So this is what we got. When they are a senior citizen, okay, their churning rate is nearly half of it. Okay, among the total count, nearly half, which means the 40% we got, right? So I want to perform this in this process, like taking the grouping them. See here, I'm just grouping them, renaming it, reset the index, and like getting the percentage and then like visualizing it, okay, into the bar plot. So I'm just turning all of it into a function. See here, so this will get the column name which you passing. This is percent underscore visual. Okay, it is grouping them to frame. Okay, so just renaming and resetting the index, getting the percentage, and just plot the bar plot. So this function, okay, we will use it for other columns. You don't want to type it again and again. If I pass it, it is going to give me the graph. So what we have analyzed from the senior citizen, this is a which type of data? This is a categorical feature. Okay, so based on it, we can understand these senior citizens are most likely to go out of this plan or their company. Senior citizens have churn rate of 42% than the non-senior citizens. Clear guys, what we have analyzed from this? So if they are a senior citizen, they are nearly half of the percent, they may go out of the company. That's what this data is telling us. Okay. So next thing is whether they are partners and dependents. Can we move on to this one? Okay, so here I'm just creating a subplot. Okay, and for 0 and 1, for I'm going to analyze the partner and dependents. Okay, y-axis will be the percentage of customers. I'm just grouping them based on the partner and churn value counts. I'm just getting the percentage of it, turning into the data frame, renaming it. Okay, resetting the index. Once I done it, I am passing this x value partner, and the y name will be this percentage of customers, y underscore axis. Okay, and the hue value, I want to visualize them based on the churn, whether they are yes or no. Hue, what it is, based on the color, it is going to give you the difference, right? So I'm just setting this as the 0th image, and the first image, it will be dependence. The same thing for dependence. So if I run this, I'll get 2 bar plot in a single thing. And with this, what you can analyze, tell me guys. So this color red is telling whether they are not churned, and blue means they have churned and get out of the company. And this is the percentage of customers. And if they have partner, what, like if they have partner, what it is. If they don't have partner, what it is. If they have dependents, what is the value. If they don't have, what is the value. Tell me guys, what can be the observation from this one? So the observation is, customers that don't have partners or dependents are most likely to churn, because see here in both of the no, okay, we have highest number of churn rate. Okay, if they have partner, then the churn rate or dependent, the churn rate is nearly less when you compare with the total count. Okay, so that's what the observation from this one. So next thing will be phone services. So if they have multiple lines or not, I told you, right, if they have adapted for multiple lines. So if they have phone service, they would have adapted for multiple lines. So I'm just going to use the function percent underscore visual, which we have created earlier, right? For the senior citizen we have done, right? So I want the same thing to be happen here. So I just convert it into a function. So I'll run this. And what you can analyze from here. So some of the customers, they don't adapt for a phone service. Okay. So if you have adapted, okay, when you have adapted here, yes and no. So what is the data you can analyze from here? Can you see it? So when you compare both of it, okay, this is high, the no count is high. Okay, both of this no is high. If they don't have multiple lines, the churn rate is also not, like this is high, no, they have gone out. But when you compare this, if they have multiple phone service, they have higher rate of churn. When you compare both of them, this has the higher rate when you compare with this one. Okay, when you take this percent, among this nearly half of it are going out. And next will be internet service. Okay, I'll pass this percent underscore visual. So what can you analyze from this one? So there are actually two things. Okay, one is DSL. This is a type of internet service. This is fiber optic. This is a type of internet service. Some people don't have internet service adopted. And as you can see, those people who have fiber optic, they are most likely to go out of the company. Okay, when they have DSL, the amount is less, right? Nearly 5%. But when you see here, nearly 15 to 20% of the customers are going out when they have this fiber optic. Okay, the customers with fiber optic internet service are most likely to churn, and customers with no internet are less likely to churn. If they don't have internet, they are not actually going out, most of it. So the additional service is provided. Okay, so there are 6 additional services provided for the customers with internet service, which means if they have internet service, either DSL or fiber optic, don't consider this no, because they don't have internet service. If they have adapted for the internet service, the company is providing them 6 additional options. That will be online security, online backup, device protection, okay, tech support, streaming TV and streaming movies. So I can show you the head of the data once again, data.head. So if they have internet service, okay, the next 6 thing is provided for them. Nearly this one. Okay, online security, online backup, device protection, tech support, streaming TV and streaming movies. So if they have adapted for these options or not, that will be the next question. So I'm just storing all of this additional support, okay, additional service. I'm storing it in a function, list. And we are going to see a new thing, guys, pd.melt. Okay, before going into it, so what this is, this additional service is provided for only the customers who have internet. So I'm just going to filter the data who don't have internet. Okay, so I'm just taking the columns where the internet service is available, which means if internet service is not equal to no, which means if the internet service is equal to yes, I'm going to take that columns alone. I mean that rows alone. Okay, so when you go and check the internet service, it will be present. Okay, it's not equal to no. So now, okay, so I'm just going to take this additional columns alone, which means I'm going to filter and take these additional features which is provided for them, that alone. You get it, right? So we are taking that alone, and just what I'm going to do is I'm going to use this. So now I'm getting this option, right? Totally 517 rows and 6 columns. There is some option known as pd.melt. So what this melt will do is it will just melt it. What will actually happen is these all columns are converted into a single column, and these values will come one by one below. Okay, so I'll pass this pd.melt and I'll store it in a variable. For example, melted equal to. So if you want to see it, I can go and pass it like melted. And totally you can see, right, the variable and the value, the output value. Okay, since they are same, I just combined them. That's what this melting will do. Okay, so this is done here, and I have just renamed the value into hash service. Okay, whether they have service or not, yes or no. Okay, just for our confirmation. So once I done it, okay, I'm just renaming it, converting, melting them, and I'm setting the figure size, creating a count plot, and the data will be melted. X will be the variable, and the hue value, okay, will be hash service, which means yes or no. And I'm plotting the X label and Y label. So this will give me a nice chart, and what you can see from here, guys. So this is a count, okay, not they have churn or not, whether they have service yes or service no. And nearly you can see like the online security is adopted by 3,500 customers. It's nearly 2,000 customers. This is no, right? Red is no. Okay. Can you see it? So for online backup, nearly 2,500 customers. For device protections, how much it is, you can see the count. So next thing, so whether they have internet service, and along with that, yes, I have used the melt to combine all of them into single one. Since the output is same, all of them have yes or no, okay, I have created like this. And the next thing, I'm just going to use another option where the data of churn equal to yes. Okay, I'm taking that, I'm doing the same process and I'm printing it. So this will give me whether they have churned or not. So the number of churn I'm getting. Okay, so I'm just using this option whether they don't, like it is not equal to no means they have internet service. Okay, they have adopted, and the churn value is yes. So how many it is, I'm just plotting in the count plot. And can you see it, guys? If they have online security, okay, yes, the number of churn count is less. Okay, in online backup, in device protection, and tech support. But streaming TV and streaming movies, the churn count is little bit high. Okay, so the customer, these first four options are unlikely to churn. They won't churn according to this data set. Okay, so next, the payment contract and payment method. I'll pass this function which we have earlier created, contract. I'm passing that. Okay, and as you can see, the person with month to month contract, they are more likely to go out. Okay, the percentage of customer go out or do the churn are likely high here. If they are 1 year contract, they are little bit less, but if they are 2 year contract, okay, the churn amount is very less. Okay, the month to month contract customers are more likely to churn. This is an important feature in deciding. And next, I'm just going to give the payment method. Okay, so if it is electronic check, they are going out actually a lot when you compare this data set. And the gender finally, and in this, what you can understand. Okay, what you can understand, tell me guys in chat box. Is it clear till now? You are about to end the exploratory data analysis. Tell me guys. And as you can see, it is nearly equal in both of them. Okay, the count also nearly 50-50, and the churn amount also nearly equal. So this gender is not actually a deciding factor whether they are churning or not. Okay, how I'm telling, because they are literally equal, nearly equal. So this won't play much role in deciding whether the customer will churn or not. So it's common for both the gender. Okay, Clear, guys? So the gender is not a deciding factor in this data set. So next we are going to analyze a numerical feature, and in this total charges actually there is some error. Okay, there are some empty space. I'm just going to turn it into 0 with float type 32. Okay, so this I got some error when I run this, so I just replace this, and I'm going to create a function for drawing a KDE plot. We know, right, KDE plot, sns.kde plot, which will give you a line graph, okay, in SNS, which will actually give you whether the data set is likely, whether it is Gaussian distributed or it is queued. You can analyze it. Okay, yes, it is equal amount of churn, so it won't be a predictive factor in the feature. Okay, so I'm just going to take the numerical feature. What are it? Tenure. What is tenure? How much month they are staying with the actual company, and the monthly and total charges. I'm just going to plot them. Okay, so this function is going to give me 3 plots, and you can see it, right? What's the density? Clear? So next thing, so I'm going to compare the tenure with monthly charges based on the data, and the hue will be churn. So the monthly charges, if they are high, okay, and you can see many like blue here, right? The tenure month are also less, they are likely to go out of the company. Churn is high here. Okay, and you can also see it with the total charges, and you can see some trend here. Okay, clear, guys? So this is actually telling when the tenure month is high, they are not likely going out of the company, because like they are a long time user and they are not going out actually. Okay, only a few are going. Only this less tenure customers are more likely to go out of the company, even if the amount is high. Okay, the total charges are high, the customers, they are with their company for many months, they are likely to stay with them, they are not adapting to go out. Next we are going to start the pre-processing. We have very little time, we'll try to do it. Okay, so in X I'm just going to drop the churn, okay, because that's the output, and Y will be churn. So I'll run this. Okay, so I'm going to use this minimum maximum scalar because I'm not going to scale it. Why? I'm just performing the normalization here. Can you tell me, guys, why? So I'm just going to take the numerical features and I'm going to scale them with minimum maximum scalar, which is going to convert them between a range of 0 to 1, and I'm not scaling it because when we go for scale or standard scalar or scaling, where it is required, where we have many numerical features which are in different unit, which may require different weight, that's why we go that. But here it is not necessary, so I'm just going to transform them, fit and transform with minimum maximum scalar. You can see it with the help of dot head. I'm just storing them in the same thing, and you can see the tenure value, and these things are now turned. Okay, it's between 0 to 1. And next I'm just going to take the categorical features I'm just using it as a filter. This, you remember, guys, we have just used it for the visualization, right? I'm just passing it as a filter from X. So I'm just going to use a label encoder because I want to encode all of these things. I'll just do it in a minute. Okay, so from sklearn.preprocessing, import label encoder, and the encoder will be stored here. So just this for our reference I'm just creating. So this, I think it's not necessary. Okay, so now for C in categorical features, so this categorical features are this column names actually, which we have loaded earlier. So it is going to give me one column name one by one. So I'm just going to fit them here, and once I fit it, I'm just not going for fit and transform because I need to know what is happening here. I want the data information. Okay, I want to encode it for the future, decode, I want to decode it for the future purpose. So once I fit it, okay, I'm just transforming it and storing in that column itself. And using this dictionary option, I'm just zipping with the classes and the transformed classes. Okay, this will give me, okay, I'll just print this mapping. So if I run this, you can understand why I'm doing this. So the C will be the column name. So the gender, female is mapped to 0, male is mapped to 1. Senior citizen, so okay, if they are not, it is 0, it's already numerical, so it's not converting actually. The partner no means converted into 0, so this we got it from this line, okay, for all the column. So this will be useful when we do in the later process. Next thing, Okay, I'm just going to fit and transform the y also. Y is yes or no, right? So no is turned into 0, yes is turned into 1. I'll go on get the head of x, and now we got all the numerical features. And one thing left, there are many columns actually. Okay, we want to take the important features using feature selection. Okay, and next thing will be, and we have forgot to do one thing. Okay, data.isNull.sum. We haven't checked for the null value. It's actually not present. It's 0 all the place. So if there are null value, then you have to do the imputation. We have seen about imputations, right? Many imputation methods, simple imputer, k9 imputer, all those things you can perform. Here there is no way. And as I told you earlier, this dataset output is imbalanced. So I'm just mentioning the stratify as y, and we'll do some other process also later. I'm just creating the train test split, passing x and y, test size as 0.3, random state as 42. Let me run this and get the shape of x test. So nearly 4930 rows are created for training and 2000 rows for testing. Okay, so I want to select the best features, so I'm using this F class F, which is ANOVA test. So I'm going to take the best 6 features. We have learned it in previous class, right? I think 2 days back. So I'm just fitting the data. Okay, fitting x train and y train, selecting the best 2. Okay, so xtrain.columns, select 2.get underscore support. This get underscore support will give me a boolean value. So if I pass it in the columns, I can get the important 6 column names, which is tenure, online security, this tech support, contract, paperless billing, and monthly charges. So I'll separate the xtrain selected and xtest selected. So now we go into modeling. Okay, so first thing, decision tree classifier. So I'm just going to use decision tree classifier. From sklearn.tree, import decision tree classifier. This is from tree. Okay, so in model 1, okay, in the variable I am creating an object for this decision tree classifier, and here there's option known as class underscore weight equal to balanced. Okay, I'm just, this data is imbalanced, so I'm mentioning this option which, okay, which will adapt for the imbalanced data. Okay, I'm fitting the data using x train selected and y train. Okay, y here the selected columns alone along with the output, and I am asking it to predict. Fitting it is the training part, this is the prediction part, and it is stored in answer 1. And using sklearn accuracy score, I am passing the original value and answer predicted by the machine, and I'll print it with 100 so that we can visualize the percentage. So this model is 73% accurate. Okay, and you can get a confusion matrix also. Clear? This much corrected predictly and this much corrected predictly, and these four are wrong predictions. Next, random forest classifier, I'll pass the same. Okay, x train, I'm fitting it and predicting it, and I'll get the score here. Okay, it's 0.76%. Or if you multiply it with 100, this will be slightly better because this is 76% good, that is 73%. I'll plot the confusion matrix also. So next thing will be support vector machine, support vector classifier. So the score here is 72%. So it seems like we have to do further more changes with the data set and further processing, okay, including outlier detections and so on, that will improve the accuracy furthermore. Okay, and I'll plot the confusion matrix. And finally we are going to use XGBoost algorithm. This is XGBoost classifier. Okay, so I'll run this also and get the score of this algorithm. So this is 77%. Okay, I hope this will be good among these, all of these things. Okay, this one is the best, right? 77. I hope one is 76, second one. So we'll use XGBoost model 4 for the final predictions for building a predictive system. Okay, so I'm just getting the features. So I'm going to build a predictive system. Listen guys, so link is invalid. I'll inform my team, they'll sort it as soon as possible. Okay, just listen to the class, we'll see about this one. So now I'm going to build a predictive system. So why I'm doing it is if I want to pass for only one customer, so these are the 6 features which I'm passing to the machine and trained it. Okay, now if I want to predict for one customer, I want to enter all these values for that customer alone, which will give me the output. How am I doing? So I'll get all these input from the inputs from the user, and I'll store it in a list, okay, and I'm converting them into an array, okay. Once I done it, I'm just reshaping it with 1 comma minus 1. So why am I doing it? Because in the training part to the model we have given an entire data set with many rows. Now I'm going to give only one row, so it won't confuse the machine. So I'm just giving 1 comma minus 1, which means one row and all the columns. So once I reshape it, I'm just going into pass to the machine model. So here we'll select model 4 because it is best to predict the input, the array which we have just reshaped. And I'll print the answer. So if the output is 0, which means the chances of churn is no, and if it is else, it is yes, okay. So here I given the all the features which is necessary, okay, and I'm creating a list, and based on it I'm using a for loop, okay, and appending it with the list. So finally it can be reshaped and given to the machine. So I'll just run this and run with this one. So enter the tenure, I'll give it as 6 months, okay. And if they have online security, where it is, find it guys. So this I just copied from which we have printed earlier, right? So this is what the use case is. Now if you want to predict, you want to know, right, which is which, okay. The online security, if it is no, it is 0. So I'll tell the online security is 0. Okay, the tech support, we'll search for tech support here. So the tech support, I'll tell it as yes 2. And the contract, which type it is, contract is, I'll tell it as month to month, okay. It is a month to month contract. And whether it is a paperless billing or not, okay, I'll give it as yes. And the monthly charges I want to enter. Oh, so what is the range of monthly charges we are having? I'll see it here. Okay, it's nearly in that, so I'll pass a monthly charge here. For example, I'll pass it as 30. Now it is stored in this inputs, okay. All these values which I have entered, if I print this inputs, it is going to be there. So this is a predictive model. This will be now turned into an array, reshaped and given to the model to predict that answer alone. It will print the output which is predicted, okay, for this row alone. This is a single row, so based on it, it will give me an output. So for this data, the chances of churn is yes, okay. The output the machine given is 1, okay. So for like this, the company can perform for different customers and try to get the answer whether they are prone to churn or not, okay. So this is what the entire thing which we have done in today's class. Is it clear, guys? Is it clear? Okay, I think there is some issue with the attendance link, so don't worry. today's attendance link will be shared along with tomorrow's class. Okay, I hope there is some issue with the attendance link. It's not sorted till now, so the attendance link for today will be circulated in tomorrow's class along with tomorrow's attendance link, so we can do it together. Okay. Yes, the model 4 actually it is XGBoost. So it's not from sklearn actually. From XGBoost you can import, whereas model board XGBoost classifier. Okay. In previous class we have learned how XGBoost is working, right? And this is how we can import XGBoost classifier, or regressor is also available from this XGBoost, and you can create an object for it. Okay, fit with the X train selected columns alone along with the Y train, which is the output, and you can ask the model to predict, and finally we are comparing the score. Okay. Sorry, it seems like there is some issue with the attendance link, so it will be sorted in it will be circulated in tomorrow's class. Today's attendance link will be circulated in tomorrow's class. So that's it guys, thanks for watching. So tomorrow's class we'll see a regression problem. We'll try to repeat the same, okay, with that also in regression. So I hope we can see you in tomorrow's class. Thank you guys.